Hey everyone, and welcome. Today, we are diving into a topic that, believe it or not, has been around since the 1960s, but can still pop up and make a huge difference in your next Python tech interview. We're talking about ASCII. It might sound a little old school, but getting a handle on it really shows a depth of knowledge that interviewers love to see.
So, let's just get right to the big question. Why on earth should you care about a code standard from the 60s when you're applying for a cutting-edge Python job? Well, it turns out this relic is actually the bedrock of how computers handle text. Knowing it is a key differentiator. Let's break down exactly why.
So here's our game plan for this explainer. First, we'll cover why ASCII is still a big deal. Then we'll jump into the essential Python tools you need to work with it. After that, we'll see how it actually applies on the job, and we'll wrap it all up with how to use this knowledge to absolutely ace your interview.
All right, let's kick things off with Section 1. Why does ASCII still matter? Before we write a single line of code, it's so important to understand what's really happening under the hood when a computer sees the letter A versus, say, the number 8. So what is ASCII really? Well, it stands for the American Standard Code for Information Interchange, which is just a very fancy way of saying it's the original digital alphabet. It's basically a universal map where a 7-bit number corresponds to one specific character, whether that's a letter, a number, or a punctuation mark.
And this gets us to the most fundamental concept here. Computers don't see letters, they just see numbers. ASCII is the dictionary they use for translation. So, for example, a capital A is always the number 65, B is 66, C is 67, and you get the idea. This is super powerful because it lets a computer sort, compare, and manipulate text using just simple math.
So you might be thinking, what about UTF-8? Isn't that what we use today? And you're right, but here's the key. UTF-8 didn't replace ASCII, it expanded on it. The first 128 characters of UTF-8 are exactly the same as ASCII. That's what backwards compatible means. So when you learn ASCII, you're not learning something obsolete, you're learning the foundational block of the most common text encoding used on the entire web today.
Okay, enough theory. Let's get practical and see how Python helps us work with all of this. We're going to look at the core tools that let you manipulate characters and, yep, even create a little bit of art.
Right out of the box, Python gives you two super handy built-in functions for this stuff. If you have a character, say A, and you need its number, the ord function, think ordinal, will give you back 65. And to go the other way, the chr function, think character, takes that 65 and gives you back the letter A. These two are your fundamental translators.
But hey, it's not all just about converting single characters back and forth. We can have some fun with this and be practical at the same time. You've probably seen those really cool stylized text banners when you run a command line tool, right? That's ASCII art, and you can create it super easily with a great Python library called pyfiglet.
And the best part? It's ridiculously easy. I mean, look at this. You just import the library, you call one function with whatever text you want, and you print the result. That's it. In just 3 lines of code, you've got a professional-looking banner for your app startup message or your log files.
And boom, here's what you get. Clean, stylized, eye-catching output right in your terminal. And this isn't just for show, it's actually a fantastic way to improve the user experience of a command line tool or to make really important messages in your logs basically impossible to miss. Okay, so we have the theory and we have the tools. Now for what I think is the most important part. How does this stuff actually apply on the job? Let's connect this knowledge to the real-world problems that you're actually going to get paid to solve.
This table really helps connect all the dots. Let's just walk through a couple of these. For a software dev, like we just saw, ASCII art is awesome for making your CLI tools look professional. But now, look over at the DevOps or backend dev role. Here, understanding encoding is absolutely critical. Imagine you're debugging a web app and a log file is just filled with gibberish or the whole thing crashes with a Unicode error. That almost always means some service sent data that wasn't pure ASCII and your system choked on it. Knowing the difference between ASCII and UTF-8 is how you fix that. Or for a network engineer, when you're looking at raw HTTP headers, those are often pure ASCII. You might use ord to hunt for weird, non-printable control characters that could be a sign of trouble. You see, these fundamentals really do pop up everywhere.
And all of this brings us to the final and most critical section, acing your technical interview. This is the payoff. Let's zero in on exactly what you need to know and say to really impress your interviewer.
Think of this as your pre-interview cheat sheet. You definitely want to be able to explain the basics of ASCII and its relationship with UTF-8. Be ready to code a quick example with ORD and cronc functions. And for sure, talk about real-world scenarios, like inspecting network packets. But most importantly, talk about troubleshooting. Trust me, if you can clearly explain how you diagnose a Unicode error, you're showing that you're not just a theorist, you're a practical problem solver. That is a huge green flag for any hiring manager.
So here's the bottom line. Knowing about ASCII isn't about memorizing some historical fact. It's about proving that you understand how data itself actually works at the most fundamental level. When you can explain that, you're telling an interviewer that you have the deep foundational knowledge that's needed to be a truly great engineer.
So there you have it. You now have the tools to connect a 1960s standard to a 21st century job offer. So the only question left is, what foundational concept are you going to master next?